You buy a used EV for less than half the price of a new one. You check the tires, inspect the exterior, and take it for a test drive. The dealer tells you,
"The battery is in great shape. You can get about 80 miles on a single charge."
but after a few months of driving, you notice something isn't right. Even with a full charge, the vehicle struggles to go more than 50 miles. Then comes the estimate for a battery replacement, $9,000. Before buying the car, you checked everything you could see. But there was no way to know how the battery, the most expensive component in the vehicle, had actually been used. But here's what's interesting. That information was there all along, stored inside a system that had been carefully tracking the battery's history from the very beginning. It's called the Battery Management System, or BMS. Today, we're taking a closer look at BMS, one of the key technologies that determines how long, how safely, and how efficiently a battery operates. Subscribe and follow along. Let's think about it this way. To stay healthy, we regularly check our blood pressure, monitor our blood sugar levels, and visit a doctor when something doesn't feel right. No matter how strong or healthy we may be, our bodies can suffer if we keep pushing them without proper care. The same is true for batteries. Even when built with high-quality materials, a battery's performance can decline quickly without a system to monitor and manage it properly. That system is BMS. Like a doctor monitoring a patient's health, BMS continuously checks the battery's condition to help it operate safely, efficiently, and reliably. So, what exactly does BMS do? BMS has three major jobs. First, real-time monitoring. BMS continuously measures the battery's current, voltage, and temperature while the vehicle is driving, while it's charging, even when it's parked. This matters because an EV battery pack is made of hundreds or even thousands of connected cells. If even one cell has a problem, the entire pack's performance and safety can be affected. That's why constantly monitoring the battery's condition is so important. Second, cell balancing. Imagine 4 people sharing a pizza, but one person eats more than half of it. That's not just unfair. That person will probably end up feeling sick. Battery cells work in a similar way. Each cell has slightly different capacity, internal resistance, and levels of degradation. Over time, those small differences can create imbalances in state of charge. BMS adjusts those differences and helps keep the cells balanced, so no single cell takes on too much stress. Third, SoC and SoH estimation. SoC, or state of charge, is similar to the battery percentage shown on your smartphone. It tells you how much charge the battery has right now. SoH, or state of health, indicates how much of the battery's original performance remains compared to when it was new. BMS continuously calculates both values while protecting the battery from overcharging, over-discharging, and overcurrent. When these functions work properly, the battery can last longer and operate more safely. Now, let's look at a real-world example. The 2015 Nissan Leaf used an air-cooled battery system to manage heat. The 2015 Tesla Model S used a liquid cooling system to control battery temperature more actively. As a result, the difference in battery degradation between the two vehicles was nearly twofold. Charging habits also affect battery life. In 2025, Geotab analyzed more than 22,700 EVs. Vehicles that frequently use DC fast charging showed an average annual battery degradation rate of 2.5%. That's a noticeable difference compared with 1.5% for vehicles that used fast charging less than 12% of the time. Fast charging is convenient, but it also generates heat inside the cells very quickly. If that heat isn't managed properly, cell aging can accelerate. So even with the same lithium-ion battery chemistry, the outcome can change depending on how the battery is managed. BMS detects and controls risks like these. When DC fast charging is used, BMS determines how current should be distributed, and when battery temperature approaches a critical level, it determines how to prevent potential issues before they occur. And this role is only going to become more important. Batteries are expanding beyond EVs into ESS, drones, robots, and urban air mobility, or UAM. As battery systems that require both high power and high safety continue expanding into new applications, the role of BMS will become even more critical. So who's in the best position to understand and fine-tune a BMS? Battery manufacturers may have the edge, since they build the cells themselves and understand how those cells behave. The better they understand the cells, the more precisely they can manage the battery. LG Energy Solution, for example, introduced BMTS, or Battery Management Total Solution, which combines traditional BMS with cloud and AI-based software. Using machine learning and cloud technology, BMTS collects and monitors field data, delivers real-time battery condition updates to users, and predicts battery material degradation and remaining lifespan. In 2024, LG Energy Solution also partnered with Qualcomm to commercialize a BMS based on a system-on-a-chip architecture. With computing power up to 80 times greater than conventional systems, this type of BMS can diagnose battery conditions faster and more accurately. And there's an area where these advances mean much more than simply improving EV performance. An EV battery doesn't become completely dead just because it's no longer good enough for a vehicle. The driving range may be too short for EV use, but that same battery can still work well in ESS applications. This is especially important because the average battery capacity of EVs increased significantly by about 167% between 2015 and 2024. That means when today's EVs retire, the pool of batteries available for second life applications could be much larger. A real example is Redwood Energy. The battery recycling company collected used EV batteries, reused them as ESS, and built a second life battery system for Crusoe's AI data center microgrid. This is where BMS data becomes critical. How was this battery charged? How often did it use fast charging? What temperature conditions was it exposed to? Without the usage history and degradation data stored by BMS, it's hard to know whether a battery can be reused or not. Put simply, BMS data is the battery's medical record. Now let's go back to the used EV story from the beginning. When you buy a used EV, the biggest concern is usually the battery. From the outside, it's hard to know how that battery has been used. But if diagnostic technologies like BMTS are working properly, you can immediately access a battery condition report. In the US, asking for a battery SoH report is already being promoted as a useful tip when buying a used EV. The BMS market is growing fast. The global market is estimated at around $10 billion in 2025, with annual growth expected to exceed 15% through 2031. EVs are growing too, and BMS isn't just for EVs. As we covered in the last video, batteries are moving into ESS, robots, drones, ships, and urban air mobility. Wherever batteries are used, BMS is needed. The same goes for autonomous driving and SDVs, or software-defined vehicles, which are becoming major topics right now. Cars of the future won't just be machines that move people around. They'll be more like computers that continue to evolve through software updates. And in that kind of system, the battery won't just be an energy source. It will become critical infrastructure that keeps the entire system operating reliably. So from now on, don't look only at a battery's materials or specifications. Also consider how the battery has been used and what condition it's in. BMS provides important clues that help us understand that information. So the next time you choose an EV or evaluate the value of a battery technology, remember what we talked about today. If you want more battery insights, hit like and subscribe. And be sure to turn on notifications so you don't miss our next battery deep dive.